As mentioned previously, there has been over a 100-fold increase in AC line noise in the last 25 years. What's just as critical is the character and bandwidth of the noise has changed dramatically. In as late as 1980, most electronic circuits used large transformers and linear power supplies. With the massive rise in personal computers for both home and office, the character of the AC noise changed forever. 25 years ago, AC noise was mostly limited to 60-cycle harmonics up to almost 400 Hz, followed by virtually immeasurable noise levels up to approximately 50 kHz. Most of the noise appeared in the AM radio band and beyond from 200 kHz to 1 GHz. This is significant because it's the model or architecture of nearly every AC conditioning filter produced today. Some engineers have created AC conditioners utilizing multi-stage filtering, special ferrite materials, or exotic wiring and capacitor topologies. However, all these designs are merely refinements of filters that were designed by Bell Laboratories nearly 100 years ago. They were tremendous engineers, but their designs were created to meet the standards of the 1920s, and AM radio was the pinnacle of technology. All electronic circuits were vacuum tube, and nobody had designed a switching power supply or microprocessor. In 2006, we're faced with a new world, new technologies, and a properly designed AC filter must meet today's and tomorrow's challenges. Though it is as important as ever to filter out RF bandwidth, it is just as important to reduce noise in the audio band or lower video band, particularly where all the low-level harmonics will occur, 2,000 to 20,000 Hz for example. This is significant for both high-resolution audio and video. It affects video because the bandwidth in video covers both audio and RF frequencies. The sheen, brilliance, black level, and black to gray definition depend on extremely low noise AC power. For the recording and playback of premium audio, any noise in the upper octaves is devastating. This is because of the way we hear music and in the way in which musical instruments work. For example, if we're listening to music at an average level of 95 decibels, most of the frequency content will be in lower mid-range and bass frequencies, and this will be primarily sustained energy. However, the harmonics, upper partials of music, as well as all the acoustic ambient information, percussive transient attacks, and high-pitched instruments will be running along at a far lower decibel level. In fact, a great deal of information in the upper frequencies will be 40 decibels, 60 decibels, or even 80 decibels below the upper signal level. Nevertheless, this is how we hear music. We are capable of deciphering layers of information simultaneously, and often it's the low-level sounds or signals that are the most prized. So, if we are attempting to faithfully reproduce audio and video material, any induced AC noise will clearly contaminate and distort the signal. For today's applications and expectations, contaminated low-level signals are unacceptable. Prior filtering schemes, such as ones used by other manufacturers or the filtering Furman employed before developing linear filtering technology, work by filtering or knocking out specific radio frequencies at fixed impedance. Far too often, this can create a noise attenuation curve that resembles a roller coaster. These filtering schemes assumed impedances were constant, which is far from realistic. If noise reduction is nonlinear and subject to strong ringing patterns that vary with load and dynamics, the AC filtering can actually add noise at some frequencies and filter out important fundamental information at other frequencies. In other words, a nonlinear filtering design is akin to a poor job of equalizing recording, or more specifically, a very poor loudspeaker crossover design. Or in video, it would be like very vivid reds and greens with horrible blacks and yellows in a video presentation. In a calibrated system such as in a recording studio, this is simply unacceptable. Furman's linear filtering technology is engineered to address these real-world, present-day needs. It reduces AC noise across a very wide bandwidth and does so in a linear fashion. This real-time AC line noise analyzer shows what we're talking about.